So here we have a GCSE exam question on cumulative frequency. So we've got a table of data and we're going to have to change this from frequency to cumulative frequency. So that's the first thing. And then in part A we've got to work out, well, if 3/4 of the people pass the test, okay, so these are the marks that people got in a test, we're going to use a cumulative frequency graph to estimate what that pass mark was. So a nice little problem for part A. And for part B, we've got 2 people chosen at random, and they now introduce a different topic in a sense. They introduce probability. So we know that there are 120 people altogether, they tell us here, 2 of these 120 people. So we've got to calculate some more numbers and divide by 120 to get the probability and give the answer based on these 2 questions here. So okay, so this is the sort of question that you get on the exam paper, usually towards the end. It's pretty tricky, particularly in part B, and typically will be given something like 8 to 10 marks. So well worth getting all of these questions right and do it carefully. Okay, let's have a look at the examiner's remarks and see how people actually did. Well, it says that in part A, most candidates attempted cumulative frequency with some success. Okay. However, a significant number of candidates plotted at midpoints. Okay. It's when they should have been looking at the quartiles. Anyway, they plotted at midpoints, or they read across from 90 rather than 30. Now we'll have a look at that and see why it is that mistake was made. Okay, so it should have gone across at 30, but for some reason went across at 90. Overall, they say the quality of the graphs drawn though was good. All right, so people drew a good cumulative frequency graph, even if they got certain things wrong. Part B, however, wasn't well answered, consistent with questions on this topic set previously. So whoever wrote this, the examiners are used to seeing people fail at this kind of probability using a cumulative frequency diagram, it looks like. So they're not surprised that people just didn't get this part B correct. Well, let's see if we can do it. And it's a challenging question, but knowing what we do about cumulative frequency and hopefully having also a good understanding of probability will enable us to get all the marks. Alright, so the table shows a summary of the marks scored by 120 people in a test. And we've got the marks here between 0 and 20, 20 and 40, 40 and 60, 60 and 80, and 80 and 100. So these are equal class intervals. So that's a good start. What we're going to add to this is a new column of cumulative frequency. So that we can draw a cumulative frequency graph rather than a histogram. So we've got 8 to start with, so we'll write 8. But now we add that 8 to the 12 so that it accumulates. So 8 add 12 gives us 20. Okay. Now remember, it's got to add up to 120, so we've got an automatic check here. Let's see if it does. 20 add, so we're up to 20. 20 add 46, it's going to be 66 now. 66 add 35, well, that's going to be 101. So we're at 101 now. And if we add 19, that gets us to 120. So good. That's given us a little check. We know that our cumulative frequency column must be correct. We can also do another thing. We can say when we plotted on the cumulative frequency graph, we're no longer looking at this frequency column, we're looking at this one. And remember, because it's cumulative, we're not taking an average between 0 and 20 in this class interval. We're looking at these values here. So it's going to be 20 against 8, 40 against 20, 60 against 66, 80, 101, and 100 to 120. So now we're ready to draw our cumulative frequency graph. And we'll come back to this pass idea in one moment. Okay, so let's use a red pen so we can see it really clearly. Okay, so we're going to start with 20 to 8, so the mark of 20 at the end of this class interval, there are 8 people, so 20 to 8, so that's a mark here. Okay, 40 to 12, so we go up here. Again, this is the bin between 20 and 40, but we're using the end of it, so up to 20, so not up to 12, up to 20. So mark that there. And then we've got 60, 66, 60, 66, so that's here. And did I say 60? Yeah, 60, 66, 80, 101. 80 now, up to 101, so that's just between there and there, so it's about there. Okay, and now 100 and 120. 100 and 120 marks the end of our cumulative frequency graph. Now we've got to join those points together, and we're looking for that ogive shape. Some people say S shape. It's not quite an S. It's technically it's an ogive shape, but it's this quite narrow, quite small gradient here, and then it goes up. In the interquartile range, it will go up fairly straight then, just a slight bend there, and then it will again tail off usually, and it does seem to tail off here just slightly as it completes its path. Okay, so let's now draw that. Oh, and we'll draw it from here, because I don't think anybody got a negative mark. I don't know, but it seems unlikely. And so 0 is where we start from. Okay? Okay. So there we go. Pretty good, I think. That seems to be going through all of those marks. And although we could have drawn a slightly different path, hopefully we'll have questions about the interquartile range where things are fairly predictable. So it's mainly this bit here where we get the reliable data. Now, part A, 3/4 of the people passed the test. And we saw in the examiner's remarks that some people then went, well, there are 120, so 3/4 of the people, 90. So they drew across from 90, and that wasn't correct. Okay. Now, if 3/4 passed, then 1/4 didn't. So we need to think about going above the quarter line. Okay. So the halfway point, obviously, is, let's just use a different pen here. The halfway point is at 60, so that's the median. Okay, and the lower quartile must be at 30, so this is the lower quartile, and so this is the upper quartile at 90, and so we want 3/4, that's a large amount, so all of these above that 30 line there, passing the test. So 3/4 passed the test, so it's the amount above, not the amount below. Okay, so let's draw across from the lower quartile then. Okay, and where it intersects with the line, or the curve rather, then we're going to get the pass mark. So an estimate anyway of the pass mark. So I think it's going to go down like that. So that gives us a pass mark of, I would say, 40, let's say 48, 47 or 48. Let's estimate it at 47. So not much room here, so use a fruit cube to estimate the pass mark. Est pass equals 47%. And just check again that we're reading our scale correctly. So each of these little squares must be 2 because we've got 5 between 40 and 50. So we've got 46, 47. So estimated pass mark, 3/4 of the people passed the test. So our estimated pass mark is 47%. Okay, that's part A completed. Now the tricky part, part B. So 2 of these 120 people are chosen at random. We've got to work out the probability that both scored over 60. Okay, so now we're working the other way to find out how many people scored over 60. And it's important, they've put it in bold, that we think about over 60. So we're going to go up from 60 until we intersect with the curve, and across to find how many people we've got. And we can read it off as 66. So we've got, let's write that down, we've got 66 people, but it's over. So in fact it's 120 minus 66, because we're looking at this area here. So it's 120 minus 66, or we could just count down 10, 20, 30, 40, 54. So that's going to be 54 people scoring over 60. So 54 people. All right. Now we've got the number of people who scored over 60. We can work out the probability. We've got, well, we've got to be careful here. We've got 2 people. So first of all, let's take one person. 54 out of 120 must be the probability that that first person scores over 60. We've only got 54 people out of 120, so that's our probability of choosing somebody who scores over 60. Okay, now we've got a second person. Now that's pretty unlikely, so we're going to multiply. Okay, that's bringing the probability down, so we're going to multiply by another probability for the second person. Well, there are only 53 people left. We've chosen one already, so it must be 53. And it must be out of 119, because we had 120, we've only got 119. So we've got non-independent probability, and that's why this part B is rather tricky. Okay, now can we simplify these fractions, because this is a lot for us to multiply? I think we can with the left hand one, so let's just use a different colour. 54 divided by 6 is 9, so 9, and 120 divided by 6 is 20. Okay, so that's made our task a little easier. It's still quite tricky. So 9 times 53 over 20 times 119. Well, I can do that straight away. 20 times 119 is 2 times 119 times 10, so it's got to be 238 times 10 is add a 0. So now we've got 9 times 53 out of 2,380. Well, at this point, I'm just going to simply multiply. I could easily use the calculator if I'm allowed, but 3 times 9 is quite easy, 27. Carry the 2. And 9 times 5 is 45, plus 2, 47. So I've got 477. And if I'm allowed to use a calculator, I will do a double check. Okay, so 2,380 in the denominator. And I am going to use a calculator now just to give that a little check. That's a very complex looking fraction. Let's have a look and see what that comes to. So approximately equal to, okay, 0.2 or 0.200. Yeah, let's round it up to 20%. Okay, which sounds about right. Okay, so I'm happy I've got that one right. Let's go then to part 2. So work out the probability that one scored over, one of these 2 people I guess, one scored over 80, so 80 this time, the other scored 80 or under, so now we've got an under-over, or over-under. This really is quite a complex question. So, first of all, I need to go to my mark here and forget this purple one now. I need to go to this. In fact, I use the same kind of pen, but I need to draw a line up from 80 till it hits the curve, and then go across, I think from here, so it's going to be there. So I'm going to call that 101. Okay, so using the same idea here, we might have, what have we got? We've got 19, so 10 and 9, 19 over. So if I pick my first person, then I'll have a probability for my first person of 19 out of 120. And that needs to be multiplied by the second person. Well, the second person has to be under, so that's going to be 101 out of 119. So that's possible, but it occurs to me that it could be the other way around, that the first person could be under and the second person could be over. So I think what I'm going to have to do, because there are two ways of getting this, I'm going to have to add. So I'm going to put brackets around here and add the other scenario, which would be that I have my first person is actually under 80. So that would be 101 then out of 120, because he's the first person, times the second person who gets 19, but because he's the second person, 19 out of 119. Okay, so assuming my logic is correct there, I'm going to use my calculator for this and make sure that I'm typing it into the calculator correctly by looking at the screen and making sure that is reflected by this. So now I've got 19 times 101 plus 19 times 101 over 120 times 100 plus, yeah, okay, so we've got the denominator is going to be the same, and we've got 1919 out of 7140. Now, does that sound correct? I'm going to just check by doing it a slightly different way. If I now multiply 120 times 119, then I get 14,280. And if I do 19 times 101 times 2, then I get 3838. And so that confirms, maybe I should have done it in another colour, that confirms what the calculator told me, that the answer must be, there we go, must be 1,919 out of 7,140. Phew. Okay, one final little check, just out of curiosity really. I really wonder what it's going to be. Now, it's going to be more or less. I'm not entirely sure, to be honest. Let's just check on the calculator again. So use the SD button. How do we get approximately equal to, so it's more, 27%.